This is video number 3 for sections 8.3 and 8.4, Basics of Simplifying Complex Fractions. The final skill in this lesson is called simplifying a complex fraction. A complex fraction means a fraction that contains other fractions within it. And you can see here from this example what I'm talking about. Well, that's considered a big mess, as you can imagine, and so when we're presented with a complex fraction, we try to simplify it, which just means we try to rewrite it in a way so that the answer is just a simple fraction with a single nice numerator and a single nice denominator. In this video, as we've done with some of these other topics, let me go ahead and deal with the situation where we're just talking about numbers, and then in the videos to come we'll start throwing in the x's. There are actually two different methods that you can use for simplifying a complex fraction. Sometimes method 1 is easier, and sometimes method 2 is easier. So I want to show you both of them so that you will be prepared. Method 1 goes like this. This problem says 1/2 over 3/8. Well, you have learned before that a fraction bar really just represents the operation of division. And so 1/2 over 3/8 can be thought of as simply 1/2 divided by 3/8. Well, method 1 says, look, if you've just got a single fraction up top, and you've just got a single fraction down there on the bottom, just take it and rewrite it using the division symbol, 1/2 divided by 3/8. And as soon as you do that, this is now a very simple problem to work out. How do I divide fractions? I don't. I change to multiply by the reciprocal. Then I look for opportunities to cross cancel. I've got a common factor of 2 there. And finally, I multiply across 1 times 4, 1 times 3. The final simplified answer here is 4/3. So we simplified this complex fraction. It turns out that this thing is really just equal to the simple fraction 4/3. I would say on a problem like this, method 1 is a great way to go. Pretty simple. But when the problems start to get more complicated, method 1 takes a long time. And so this is where method 2 comes in. Again, let me demonstrate it for you on our simple example here. Method 2 takes a little bit of a different approach. Method 2 really focuses in on wiping out the little fractions. And here's how it goes. Take a look at all of the little fractions in the problem. This one has 2 little fractions, 1/2 and 3/8. And then focus on the little denominators. I'm talking about the 2 and the 8, the denominators of the little fractions. Go off to the side and ask yourself, what is the LCD of those 2 little denominators of 2 and 8? In other words, what's the smallest number that both 2 and 8 go into evenly? And of course that's pretty easy. That would just be the number 8. 2 goes into 8, 8 goes into itself. Whatever you decide upon as the LCD, in our case 8, you then take that number, you go to the big fraction. So far, see, I was focused on the little fractions. Now I'm focusing on the big fraction. What are you always allowed to do to the top and bottom of a fraction to keep it equivalent? The answer is multiply or divide by the same number. Well, I'm going to multiply the big top by 8, and of course, to keep things consistent, I'll have to also multiply the big denominator, the big bottom, by 8 as well. I've created now 2 separate problems. This fraction bar in the middle is separating these problems. Maybe even a better way to write it than what I've done is to write it this way. The top is 1/2 times, how do you do a fraction times a whole number? You write the whole number over 1. And then the bottom problem is 3/8 times 8 over 1. This might even be the better way of writing what you're going to do. Now just carry out each individual multiplication problem. Of course, I can do some cross-canceling on this one. Notice that When I multiply across here, I'm going to get 1 times 4, but on the bottom, I'm just going to get 1 times 1, which is 1. That means there is no bottom. 4 divided by 1 is just 4. The numerator has now simplified to just a nice whole number. Okay, now I go to the bottom part. This one's even better. The 8's cancel out. Notice again, all of the little denominators have turned to 1's. You have made a mistake if that doesn't happen. That's the whole point of method 2. If they're all 1's, you don't have little fractions anymore. You just have 3 times 1, which is 3. Here is the final simplified answer, 4/3. Notice, of course, it's the same thing we got before. We just got there using a different method. In the videos that follow, I will show you how these two methods play out in more complicated situations.